Department of Biotechnology, Chaitanya Bharati Institute of Technology. Exploring the synergistic antibacterial action. Antibiotic and zinc oxide. Nanoparticle infused polymeric films. Project by Sudheshna Sharvani. Internal guide, Dr. K. Dharmalingam. Introduction. Antibiotics are effective against bacterial infections by targeting folate synthesis, ribosomes, or cell walls, but bacterial resistance mechanisms like destruction, modification, and efflux have emerged due to misuse and improper dosing. This resistance, termed antimicrobial resistance, AMR, poses a global threat, impacting human, environmental, and animal health as bacteria evolve to evade antibiotic effects. AMR poses a significant challenge to wound care by reducing the effectiveness of antibiotics and antimicrobial treatments, leading to delays in wound healing and increased morbidity and mortality due to the prevalence of multi-drug resistant strains. Alternative antibiotic approaches include nanoparticles, vaccines, antibodies, probiotics, bacteriophages, peptides, phytochemicals, metals, and antimicrobial enzymes. Metallic nanoparticles are promising due to their broad-spectrum antibacterial properties and reduced susceptibility to resistance development, offering potential solutions to combating microbial infections. Amongst the metallic nanoparticles, zinc oxide, ZNO, nanoparticles have garnered significant attention due to their potent antibacterial mechanisms, which are believed to stem from several factors, including the release of Zn+2 ions, the generation of reactive oxygen species, or interactions between the nanoparticles and bacterial cell walls. Carboxymethyl cellulose, CMC, a natural polymer, is widely used in wound dressing applications. CMC not only facilitates the formation of the extracellular matrix and supports re-epithelialization, but creates an optimal moist environment crucial for the wound healing process. To tackle this antibiotic resistance in the wound care industry, this study aimed at using the synergistic effect of nanoparticles and antibiotics by integrating them in polymeric films, which could be used as a potent wound dressing material. Objectives: to prepare different formulations of polymeric films loaded with antibiotics and nanoparticles. To characterize and study the properties of the prepared films, understand the drug release pattern of the prepared films. Novelty. This particular study aimed at synthesizing polymeric films derived from hydrogels and have both antibiotics and nanoparticles infused in them. This offers a dual advantage: antibacterial property due to the nanoparticles and antibiotics, and reduction of pain, while removal of the dressings due to the use of hydrogels. The novelty of this work is listed below. There is no existing research on this specific combination of the polymer, nanoparticles, and antibiotics. The polymeric films produced using this formulation tend to exhibit a very good swelling ratio, which is not normal in usual scenarios. Workflow. This study aims at synthesizing ZNO nanoparticles, analyzing the structure and morphology of the nanoparticles using SEM, optimizing the formulation of CMC-based polymeric films loaded with ZNO nanoparticles and antibiotics, and analyzing the film's swelling properties, antioxidant properties, hemocompatibility, mechanical strength, antibacterial efficacy, and drug release pattern. Results. The analysis of ZNO nanoparticles synthesized in this study revealed that the ZNO nanoparticles exhibited hexagonal crystalline structure, spherical shape, and a size in range of 100 to 200 nanometers. The most optimal concentration of cross-linking agent, citric acid, was found to be 15%. The swelling ratio analysis of the synthesized polymeric films revealed that the films exhibited a very good swelling ratio. thereby making them a suitable material for wound-healing bandages that could absorb the wound exudates. One of the most unexpected observations was that the films with CF Prozil and ZNO nanoparticles exhibited a very high unusual swelling ratio. The films also exhibit decent antioxidant activity, very good hemocompatibility, and good mechanical properties. The porosity analysis of these films also revealed that the films were non-porous and intact. The water vapor permeability assay revealed that the films were resistant to water vapor permeation. The antibacterial activity of these films was very good, indicating their potential to tackle bacterial infections encountered in injured patients and wounds. The drug release study revealed that these films allowed the drugs to be released over a period of time. This study also revealed that these films exhibit a controlled release of drug. Conclusion: the study synthesized antibacterial polymeric films incorporating antibiotics and ZNO nanoparticles, revealing ZNO nanoparticles with hexagonal crystalline structure and spherical shape, ranging from 100 to 200 nanometer in size. Optimal concentration of the cross-linking agent, citric acid, was determined to be 15%, while the polymeric films exhibited excellent swelling ratio, making them suitable for wound-healing bandages capable of absorbing wound exudates. Films incorporating cefprozil and ZNO nanoparticles showed unexpectedly high swelling ratios, along with decent antioxidant activity, hemocompatibility, and mechanical properties, while maintaining non-porosity and resistance to water vapor permeation. These films demonstrated significant antibacterial activity, suggesting their potential in addressing bacterial infections in wounds, and facilitated controlled release of drugs over time. Future perspectives. Future research will focus on investigating the release pattern of ZNO nanoparticles from polymeric films using atomic absorption spectroscopy and assessing the cytotoxicity of the films against human cell lines to evaluate their safety and biomedical potential. Additionally, the study will explore the biodegradability of the films to understand their environmental impact and sustainability, aiming to develop safe and effective polymeric materials applicable across biomedical and environmental sectors. Thank you.